Chapter 1, Section 2, Grandmaster. Suppose you buy a 48-inch 16 by 9, or 16 to 9 ratio, widescreen TV. What are the dimensions of the screen? So, when they say dimensions, obviously they mean the length, okay, this way, and the width this way. So we want to find these two values. But they already say that the television is 48 inches. Well, what is 48 inches? Well, when you buy a TV, that number actually represents this right here, the diagonal. Okay? So that is what is 48 inches. Okay? So using this information alone, how can we determine the length and the width? Well, there actually isn't enough information going by just that. We need something else, and that's this. Okay? So even though we don't know either the length or the width, because we know that the ratio of length to width is 16 to 9, that will actually give us the information we need. So here's how we set it up. So here, if I just draw a couple of lines here, you can see that we actually get a right triangle. And you should know that there is a special relationship when you are dealing with right triangles, and that is the Pythagorean theorem. And you would have seen this before. A squared plus b squared equals c squared. And remember that c, in this case, is 48, and we call that the hypotenuse. So let's write out that equation using our letters. So it's L squared plus W squared equals our C squared. But we know that is 48, so we just write 48 squared. All right, so now we have an equation. We can't solve for it right now because we have one equation but two unknown variables. Fortunately, this ratio here, 16 by 9, that will allow us to actually solve. 16 to 9. Okay, that must be equal to the length divided by the width. Okay, whatever the length is and whatever the width is, that ratio has to be 16 over 9. So what do we do with this? Why don't we cross multiply? Then we don't have to look at any fractions. So I'm going to get 16w equals 9l. Now what I'm going to do next is something just like we did in solving systems of linear equations using the substitution method. I'm going to solve for one of these variables. It doesn't matter which one, but I'm going to solve for L. So I'm simply going to divide by 9, so these cancel, and I end up with 16w over 9 is equal to L. How does this help us? Well, this is a relationship between W and L that we can now apply to this equation right here. So I'll just put a line separating. So my new equation becomes L squared plus, whoops, my mistake. It's L that I'm replacing, so instead of writing L squared, I'm going to write 16w over 9 squared. Okay? Because remember, this is still L, according to this equation here. Plus w squared equals, and 48 squared, that's 2,304. All right, now this equation certainly doesn't look very nice, but the good thing is notice how there's only one variable here, and that is w, which means we can solve for it. So from this point on, we're just going to do some algebra. So everything in the brackets here is being squared. So the 16 is being squared, the w is being squared, and so is the 9 in the denominator. So that's going to give us 256, that's 16 squared, times w squared, all over 81. again, plus W squared is still equal to 2,304. Okay. Now there are different ways of going on to the next step. We have like terms in here. We have a W squared here and here. There is an invisible 1 here if you wish, and you can add those together. But another technique, which some of you might like better, is to at least temporarily get rid of the fractions. Okay. And so there's only one fraction present here with a denominator of 81. So what I'm going to do is multiply both sides of this equation by 81. I'm just going to squeeze that in here. So when I apply distributive law, okay, 81 times 256W, blah, 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 divided by 81, well, these 81s are just going to cancel. So I'm simply left with 256W squared. 81 times 1W squared is just 81W squared. Simple enough. And then here on the right, I can work out 2304 times 81, which gives me 186,624. All right, so now these are combinable, but it's just a little bit easier now. So 256W squared plus 81 gives me 337W squared, and that is still equal to this ugly number, 186,624. Okay, keep in mind we're still trying to solve for W, so let's now divide out the 337. Okay, so these are going to cancel. And I'm just going to move over here. That's going to give me W squared is equal to, and in all likelihood we're probably going to get an ugly decimal right now. Yep. Okay, so this is 553.78. I'm just going to keep about 2 decimal places. This is approximate. All right, so how do we find W? Well, if W squared is this ugly number here, to find W, we just take the square root of it. And you should have a square root button. And that gives me 23.5 roughly. Okay, and I think I can put my units back. Okay, we're still in inches, so I'll put that like that. All right, so we've found the width of the TV to be about 23.5 inches. We're not quite done because the question asks for the dimensions, so we need to find the length as well. So we're going to do that, but that's pretty easy. Okay. So from down here, remember we can use this relationship to go back and forth between the width and the length. So we said that the length is always 16 times the width divided by 9. But the width we now know. We just worked that out. So I'm going to replace W with 23.5. Now remember, that 23.5 was a rounded value. So when I actually work this out on my calculator, I'm not going to use the number 23.5. I'm going to keep the original number that had all the decimals. I still haven't cleared it for my display. Divided by 9. General rule when you're rounding, you don't want to round until the very end. Okay, so that's going to give me approximately 41.8, and I'll put the units back. So remember, this is still length. There we go. All right. So the dimensions are of the TV are, it has a length of 41.8 inches and a width of 23.5 inches. If you apply the Pythagorean theorem to these two numbers and you solve for the hypotenuse, it should give you 48. And these two numbers satisfy a 16:9 ratio. So those are the dimensions of the TV. Will the TV fit inside an entertainment unit with a compartment 40 inches wide? All right, well, so we're talking about the width of a compartment. Well, chances are that's not the same width as the TV. So here's my TV from up above, and originally we said that that was the length and that was the width. Okay, but if we're trying to fit it inside some compartment, most likely, right, most likely we would consider this to be the width, how wide it is as you look at it, which would be actually the length of the TV. And we know the length from before was approximately 41.8 inches. Okay, well, if this is 40 inches, I think it's obvious that this will not fit. So the TV, unfortunately, is too big. What's a solution? Get a smaller TV, or get a larger compartment, or, well, do something else. So, no.